Guys, welcome to this first video for the materials and atoms topic of Year 11 Chemistry. I'm going to be breaking this up into a number of different short videos for this topic. This is the first topic in Year 11 Chemistry. Hopefully you'll find this helpful as you go through and do your revision or trying to understand some of the concepts. Before I get into it, just want to remind, this is particularly for my students, but throughout this PowerPoint, if you've got the hard copy of it, you'll see these little YouTube symbols throughout the course, and you also see the name of the YouTube video. If you click on that, you'll be able to go straight to the YouTube video, which will give more explanation. If you're not one of my students and you would like a copy of this PowerPoint, please feel free to email me. Here's my email up here, and I'll try and share a copy with you as well. All right, so before we start, there's a couple of things that you might want to have a look at in terms of helping you with your understanding for chemistry, because we don't specifically really go in and have a look at writing chemical formulae or balancing the chemical equations. I have put some videos together that you might want to use. If you want to have a look on my YouTube website and have a look at writing chemical formulae and balancing chemical equations, these two here. I've done some new ones. There's an older version and there's a newer version. So if you want to have a look at those, they'll be quite useful for you, because if you can really get a good understanding of how to write your formulae and balance equations, it goes a really long way to helping you out with chemistry. All right, so first off, we're going to be having a look at properties and uses of materials. And so this video here is an example of a nanobot, something that they're looking at developing in terms of helping to fight diseases, so viruses and things like that as well. And so we're just going to be having a look at some of the different properties of materials and sizes of materials as well. So there are 5 main properties. All right, so there's solubility, thermal conductivity, electrical conductivity, melting point, and boiling point. So the interesting point to start for my students is always going to think about what properties of salt do you know. So think about in terms of its solubility or how it conducts electricity. If you know, does it have a high or a low melting point? All right, and I go through these in a bit more depth in the next slides, but there is also a video here which you can look at, which goes a bit of an introduction to properties of materials. So if we have a look at solubility, solubility is defined as the ability of a substance to dissolve in another substance. So there's a couple of terms we use here. One of them is the solute, that's the substance we're dissolving, and another one is called the solvent, that's what we dissolve it into. If it dissolves a lot, it's said to be soluble. If it does not dissolve, it's insoluble. All right. There's a couple of rules in chemistry. Basically, if anything has a sodium, a potassium, an ammonium, or a nitrate ion, it's always going to be soluble. But the best thing to do is just to have a look here at the solubility table, and I've grabbed this directly from Sigma Aldrich. So if you actually have a look, I'll just move this up a bit. There is an option here. You can download this PDF from the Sigma Aldrich website, and that will show you all the solubilities of the different substances. All right, so all you've got to do is know the name of it. So if you've got something like sodium sulfate, you come here to the sodium column, you come down to sulfate there, and you'll see that it's soluble. But we would have known that anyway because it has a sodium in there. So if you're asked about solubility, I strongly recommend you have this solubility table there with you. It'll be really helpful. All right, so solubility is the ability to dissolve in another substance. If we're talking about thermal conductivity, all right, it's the ability of a substance to conduct heat. Now, heat travels through materials by causing particles to vibrate. So basically, the denser the substance is, the closer the particles are together, the easier it is to pass that vibration energy along to the next particle. So as you heat a part of a substance, those molecules, those atoms in there start to vibrate. Those vibrations get passed on to the next atoms, and that then transfers throughout the course of the substance. So if it's able to conduct heat very well, it's called a conductor. If it doesn't conduct heat very well, it's called an insulator. Okay, so an insulator will normally be something which doesn't have those particles close together, or doesn't allow them to vibrate and pass the heat on as well. If we're talking about electrical conductivity, it's the ability of a material to conduct electric current. Now, electric current is basically the flow of electrons. Okay, in order to conduct electricity and be a conductor, a material either needs to have free electrons of its own, like a metal. So later on in the next topic, you look at the structures of metals and how metals bond, and you'll find that metal atoms have this free C valence electrons, and so that allows them to conduct electricity. Or you need to have dissolved ions that can transfer electrons. So when you dissolve salt in water, you form sodium ions and chlorine ions. They allow that solution to conduct water. So something will conduct electricity and be a good conductor if it has free electrons or dissolved ions that can move from one end of the material to the other. Obviously, if it doesn't conduct electricity, it's called an insulator. Melting point is the temperature where a material changes from a solid to a liquid. The solid materials are held together by strong primary bonds. So again, in the next topic, we're going to be looking at the types of bonds that you can have. All right, but we've got inside materials, you've got primary bonds, and then holding them together, you've got secondary bonds. Okay, so that's when you're talking about molecules. So this might be a little bit difficult to get your head around without the next topic, where you're looking at what a concept of lattices and molecules as well. But basically, the stronger the bonds are, both within a substance and that are holding the molecules together, all right, depending on which one you're looking at, the stronger those bonds, the more energy that is required, and hence the higher the boiling point or melting point will be. When you supply enough energy to break the bonds, the material is no longer rigid and the atoms or molecules inside can move more freely, and that's instead of having that locked in structure, which is what a solid is, you start to get the atoms or molecules inside which can move more freely like that, and that's where you get a liquid. All right. And then finally, boiling point, which is kind of related to melting point as well. It's the temperature where a material changes from a liquid to a gas. So this is the point now where you've got those particles or atoms which are able to move over each other a little bit more. As you supply more energy, you start to break the bonds which are holding them together and they separate. Now you've got them into a gas form. Okay, the weaker the secondary bonds or those bonds that are holding the molecules together in the liquid form, the lower the boiling point as well. So those are the 5 different properties that materials can have. It's good that you have a bit of an understanding about those and keep them in your mind as we start to pick in the next topic where we look at ionic, covalent, metallic substances as well. Those properties allow chemicals to do a wide variety of functions. Now, materials, not only having different properties, also come in many different sizes. So these are some very short people here at 1 meter. Okay, normal person's about 1.65 to 1.75, that sort of thing. That's about the average height of a person. So that's our height there. And then you can see you can go through each of these is just increasing by a factor of 10. So we go down to the size of a hand, then we go down to a hair molecule. So this is what's called a micrometer. UM is a micrometer there. And so you're starting to go down here until you get to nanometers. So this is 10 to the minus 6, right? So this is millimeters, micrometers here. So this is 10 to the minus 6 meters. This is 10 to the minus 9 meters. So your red blood cells, all right, are sitting in here at about, I think it's about 7 micrometers, something like that. Okay. You've then got bacteria like E. coli. You've then got viruses here, which sit at about the 100 nanometer one. You've then got hemoglobin, which is inside your blood. Then you go down to molecules like glucose, and then an individual atom, which is what's called 1 angstrom. So a nanometer here is 10 to the minus 9 meters. So we're getting very, very small. And so you're basically starting off with atoms. Atoms make up molecules, which go up to make larger substances, okay, which all combine together to make humans at the end. So it's a good idea to have an understanding of when we're talking about the atom, we're talking about something that's really incredibly small. It cannot be seen by normal microscopes, okay? You need special equipment to be able to see them. So a nanoparticle is a very small substance that contains particles that are between 1 and 100 nanometers in size. So that's this equivalent, 10 to the minus 9 meters, okay? Nanoparticles in particular are being explored for a massive variety of uses, but in the medical industry in particular, they're having great breakthroughs, and particularly at the time of recording this video. There's obviously the coronavirus, which is sweeping the world, causing a lot of fear, and there's a lot of medical research being done on it as well. So you can see here within biomedical research here, there's a lot of things that are happening. So things like drug delivery, drug controlled release, cancer therapy, but that's only just some of the little things that it can do. I've got a little video here which you can see if I get it started. So this is the idea of what a nanobot will do. So this is obviously inside the bloodstream. You can see there was a green virus particle just there that went past. This is a nanobot which has just been injected in. What it's doing is selectively finding the virus particle and is then destroying it. All right, so the whole point of these is that they are programmable. We can get them to target specific cells or organisms or viruses to be able to get rid of them. That's very, very useful for obviously things like chemotherapy at the moment. Chemotherapy is non-selective, so it just kills off as many good things as it does bad things. So if we can get selective treatment, that'll be really, really useful. All right, so I'm going to end this video here. Next, I'm going to go into how we separate substances because they've all got different properties. So for this one, main thing to look at is to think about the different properties we were looking at, those 5 properties we had, which was melting point, boiling point, electrical conductivity, thermal conductivity, and solubility, and also the size of particles of how we go from normal measurements that we know, like millimeters and centimeters and meters, down to micrometers, which is 10 to the minus 6, and nanometers, which is 10 to the minus 9. All right, hope this has been helpful. See you in the next video. Thanks, guys. This is real love. This is real